Don't freak out about this whole idea of proof. All this means is that when you have angle, in order for us to show that triangles are similar, well, let me rephrase that. When we first talked about congruency of triangles, you had to have 3 angles that were the same and 3 sets of sides that were the same. After we did that, then we started saying, hey, you don't have to have all 6 things. You can have side, 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 angle, and so on. You're able to show less information to make it work. Same deal here. The less information we have, the easier it is to show that it works. Now we're talking about similarity here. And basically all this is if 2 corresponding angles are congruent, then the 2 triangles are similar. So basically what this boils down to being, if you have 2 angles that are the same in a triangle, you automatically have similar triangles. You don't have to show the ratios, you don't have to prove it with the fractions. You know that it works, which means you have to be able to write out a statement just by following tick marks in an angle, or in the triangle, excuse me. Because basically, that then sets up the fact that, well, how many degrees are in a triangle? 180. No matter what, if you've got 2 sets of angles that are the same, that's always going to leave you with the same amount left over for that 3rd angle. So angle basically means the exact same thing as angle. You just don't have to say it. We talked about this setup when we did angle, side, angle, and when we did angle, side with the congruencies. All you have to have is 2 angles that are the same. Boom, triangles are similar. Write a fraction, go on through bad self. It's that quick. Okay? Let me show you an example. So we have those 2 triangles. Let's determine whether or not they are similar, and if so, what's the statement? What's the similarity statement that we can write out? Now this is just taking into consideration a couple of things that you should remember. For example, that little square box in the back corner, or in the corner of the triangle, means what? It means it's a right angle. What do you know about all right angles? They equal 90 degrees, and therefore they are congruent. Right angles are all congruent. Oh, I thought you found that. So, how many degrees are in a triangle? 180. If I back out the 90 degrees in both of these, what's left? 90 degrees. So, what's 90 minus 64?
26.
Hey, look at that, it's 26. Then what's 90 minus 26? 64. Hey, wait a second. That's the same as this one. That's the same as this one. And those are the same.
Oh my goodness.
Are those triangles similar?
No.
Yeah. Now it's just a matter of writing it out. Pick an angle, follow the tick marks. Just like you would with congruent triangles, that's all you have to be able to do. CDE has to be similar to what?
K.
There you go.
It has to be in that order, right?
Yep. Yep. Because you went with 1 right angle 2. 1 right angle 2. That's all you gotta do. Now you have a statement, and you can write out all the fractions and go on. It doesn't matter. That's all this stuff means, guys. It is quite literally that fast. It's one step on top of this. You have to look at a diagram to tell whether or not you can come up with this statement, to come up with the lettering, to come up with the fill in the blank, to come up with the solve for x. That's all. Every one of these sections adds one step to the previous. Okay? But the other thing this section will force you to be able to do is to know how to draw a picture. And this is where people can have an issue. A flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby, who is 5'4", casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? Kind of like one of those problems that, what was it? No, someone stole it. Oh yeah. Every time I see a math word problem, it looks like this. If I have 10 ice cubes and you have 11 apples, how many pancakes will fit on the roof? The answer, purple, because aliens don't wear hats. So it kind of makes a lot of sense then, doesn't it? What's going to make figuring out that problem easier? Drawing a picture. So more often than not, when you have a shadow, what happens to be up in the sky? The sun, correct. Now, does it not mean you can't have a shadow with the moon? You can. But isn't the shadow from the moon still coming from the sun? Ooh. Why do you hate me? Why do you hate him? He doesn't do anything to you. Yeah. Have a heart. Scrooge. Scrooge. How do you not know who Scrooge? You seriously don't know who Ebenezer Scrooge is?
You really don't watch Carol?
Are you? You're not lying to me, are you? Ghost of Christmas Past, Ghost of Christmas Future, Tiny Tim.
Oh, that's so sad.
Wait. Are you really serious?
She doesn't know what it is either, so. I don't want to hear it. I don't want to hear it. It's a movie. It's like saying that you don't know who Harry Potter is. It's a movie. It's a movie.
I don't know which one.
It's a movie.
It's like it's a hugely classic movie from. Wow. So here's the sun. So there's the sun. And last time I checked, if you ever wanted to put a flagpole in the ground, what kind of an angle do you think it would make with the floor? Correct. So that means we probably have somewhere around here flat land and a flagpole. That's it. I drew it a while ago trying to keep up.
That's me.
I didn't have to do that. Sorry.
That's a weird flag.
So there's my right angle. I didn't want to make it that big because it's overtaking the sun. Now, if I have a sun's ray, a drop of golden sun,
That's a really weird one. That's supposed to be straight.
so the sun's ray,
Wow. Does it say how long the flagpole is?
nope,
What
but it
if
tells you how long. It tells you how long the shadow is.
50 feet?
The shadow
Wow.
is 50 feet. It says a woman standing nearby.
Is 5 feet tall and she casts a shadow 40 feet.
She's 5 feet 4 inches tall. Also creating a right angle with the ground because she's standing up straight.
Oh, that doesn't happen.
And her shadow is 40 inches long. Now remember, this is not drawn to scale.
Yeah. Gotta measure it out. Can you
Not
put
even-
the 50 feet for the big shadow?
I did.
Oh, I didn't see that. I need to put it like
So here's what you're looking at. Right now you've got two triangles.
Huh?
You have two triangles that look like this.
She has to go to the bathroom. I think she's gonna pee on your floor.
Well, she could ask to use the pass instead of having her friends ask for her. It's not a big deal.
Friend. I just don't want her to pee on
If you need to grab the pass, it's fine. Basically, what's happening here
me. She said yes.
is that you have this picture with a secondary perpendicular spot. Okay? Now, one of the things that we talked about a long time ago, talked about when two things are perpendicular to the same thing, the two lines themselves are parallel to one another. Remember when we did the whole thing about horizontal and vertical lines with lined paper? How that red line down is perpendicular to all the blue lines? If you look across on the other side, you have that other red on the tab part that you can kind of see. Those two on the outsides are always perpendicular to one another. I'm sorry, parallel. Same thing if you go with the blues, are all perpendicular to the red. Same idea. That means that these two verticals are parallel, which give you parallel lines and transversals. Also, sometimes people notice this. Here's a small right triangle. Here's a large right triangle. What do those two triangles have in common? Besides the right angle. Which other angle? Which one do they both have? Can you keep your feet off the top of the chairs like that? That's how those things are going to bend out. This one down here, it's a shared angle between the both triangles. Basically, this is an example of a reflexive angle. It's an angle that's shared between two figures. It didn't show up very often with congruent triangles because you can't really do anything with those two types of diagrams. But it does show up pretty regularly when you deal with similarity. So right off the bat, I've got right angles that are the same and a shared angle that's the same, which means you have angle, angle. Or notice, two parallel lines cut by a transversal. That means that these two angles here and here are also corresponding. So you can get it up that way, or get them to work that way as well. So between the flagpole and the lady, you've got the angle that the sun's ray meets with the floor, the two right angles, and the two corresponding angles at the tops. Whether it's the top of the flagpole or the top of her head. I don't know if she was wearing a hat. I don't know. So what happens then is that you can set up ratios. We're trying to find the height of the flagpole. Height of the girl to her shadow. Height of the flagpole is to its shadow. Get that generic setup. But I can't do anything with it now. The reason why I can't do anything with it now is because they're in two different units of measure. We have feet, we have inches, we have feet and inches combined. Now, we've said this before, whenever you're dealing with ratios with different measurements, is it easier to work with the larger measurement or the smaller? Smaller, which means I'm going to convert everything here into what? Inches. How many inches are in a foot? 12. 12. Like 16 ounces in a pound, but 12. So I got to take this ratio. (5'4" over 40 inches, x over 50 feet. So how many inches are in 5 feet? 60. So 5 feet becomes 60 inches. Add another 4 inches, and 5'4" is 64. So I have a 64 over 40 is something over, well, 50 times 12. Well, 5 times 12 was 60. Add a 0, you get 600. Does it matter at all if I simplify the 64 over 40? Nope. It does not matter because you're using a calculator. If you cross multiply and solve it, you're still going to get the same result. If you weren't using the calculator, you're trying to use your brain, a little bit easier. You don't need to. Okay. So if you cross multiply out, you get 40 times x is 600 times 64. And we get x is 960 inches. Okay. The question asked us, though, I believe it said round it to the nearest foot. Convert it back to feet by doing what? Not times 12. Divide by 12. Divide that by 12, and how tall is your flagpole?
80.
It's 80 feet tall. That's a ridiculously tall flagpole. When you think about, what's that? When you think about how tall the school is probably only, I don't know, 22, 23 feet tall. Yeah. Okay. When you start thinking about the lights, like the light poles, even the light poles by the football field, they might be 30 feet tall. Yeah. So you start thinking about how tall 80 feet really is. You know the student center? Other class period didn't know what the student center was. On campus, the big tall tower.
Yeah.
That's called the student center. The needle, little blinking light on the top. Not sure if you're serious. I think you're lying to me, just nodding. You're lying to me. Anyway, that building's about 200 feet tall. So an 80-foot flagpole is just almost half as tall as the student center. That's silly tall. The parking garage over there is about 50 feet tall. So if that's a flagpole taller than the parking garage, yeah, you start thinking about it. What's that? Yeah, and you think about it, if an 80-foot tall flagpole, then you're talking about a flag that's just monstrous to fit through there. I don't know if any of you guys have gone north on Randall Road into Crystal Lake at all before. When you get into Crystal Lake, Randall Road kind of ends and turns into a road called Rathhow Road. It splits by Crystal Lake South right by the sewage treatment plant. That's the reason why Crystal Lake South has air conditioning, because they were across the street from the sewage dump. At the sewage treatment plant there, you can see the flag on their flagpole from the corner of Randall Road and 62, not 72, I'm sorry, 62, right by where Costco is. That flag is, you can see from like 2 miles away, and it's ginormous. But the flagpole itself might only be 25 feet up in the air. I remember when that road was 2 lanes. You guys don't care. Oh yeah. And there was no Rathhow Road, you couldn't get through. Everything was 2 lanes that whole time. Randall Road was a 2-lane highway with like stop signs. It was nuts, yeah. It was nuts. My parents built a house off of Randall Road back in, I don't know, 98 or so. And it was 2 lanes when they built the house. And then all of a sudden it became 4 lanes, and then there's just traffic everywhere, and it's just an absolute nightmare. But there was nothing out there. The whole Commons area. You guys know where Jacobs High School is? Jacobs High School, right there, right off, it's in Algonquin, right off of 62 and Randall Road. Like everything is off 62 and Randall. It used to be, I don't know if you've been there before, you're nodding your head like, yes, you know what I'm talking about. Randall, or Jacobs used to be set so far back, it was all farmland in front of it, to go all the way back there. that road that went back to it, now there's a Meijer in front of it, and there's all these other shops and stuff. But that whole thing used to be all farmland up until maybe like 2000. It was about 2002, 2001, somewhere around there. They started building up. History, guys, it's good for you to learn stuff. Show you another example. Were you from around back there? Where are you from up there? Oh, you were? Nice. Yeah, my parents are right there, right across the street from Woodman's. Yeah. They built back there when that first built up, back in, it would have been 98, 99, something like that. Because I'm originally from Cary, which is, we used to drive down before 31, before all of that happened. Go down 31 to go to Spring Hill Mall. That was the happening place. Way back in the day. Here's a funny one. I'm sure that you went to Racing Rapids, the water park. I used to run that water park when I was in high school. I used to work there in the summers. The lifeguard and all that there. Did all the water stuff. Oh yeah. Way back in the day. Yeah, back in my days, studying people. I'm old. Yeah. I got one last example and I'll let you guys go. The only other weird thing that you might see from time to time is, again, using the idea of parallel lines to tell whether or not something is going to be similar. And then can you write out a similarity statement? And these are, after you do a couple of these, you start to realize that they're really not that bad. If I want to come up with a similarity statement of these two triangles, you'll notice you've got those parallel lines. Well, first of all, do you guys all see that there's two triangles? Well, sorry, there's two of them. There's the SRT and the SQU. And both those two triangles share what angle right away? S. And what happens here is that you'll see that you wind up this night, you get an overlap angle a lot of times with these. Or sometimes they'll do an overlap where you've got vertical angles like that. And then parallels going out this way, where you'll have the alternate interior, something like those. What I'm just trying to get you guys to remember is that you have all these different angle pair relationships that do show up from time to time. And it's just a matter of remembering how you draw them. Here it's pretty simple. Shared angle, these two angles are corresponding. That's all you need to show. You got two angles, you're done. Something like this, you'd have vertical angles. If you had parallels, yes, ma'am. Yeah, whatever. It's his grade, not yours. Sleepyhead. Stay with me. And then you can do your alternate interiors either direction. But you'll be given these parallel things. So it's just a matter of remembering how they look. Okay? Remember, overdraw stuff as you look at it. Just want to make sure that you see this. What I want you guys to do then tonight is, was it 6.4 page, what is it I write on there? 384, 3 through 14, and 26. Do those, please. If you give me a second, I'll put up a couple of problems for you. Get started.
If I didn't like you, everyone gifts because I'm a big gift. Oh, I have to give Jason Mama's and me.
What's up? Here's the first grouping of them if you guys want to get started. Got a few minutes to get going. I have it written down up here too for you. It's already on the calendar as well.